Hello, good morning once again. I'm not sure no if you can hear my audio properly. I hope you are not hearing weird noises in the background. Let me know sometime later kung mag-crack something ang mga audio or the likes. And should I be suddenly ejected from the meeting, kindly wait for siguro mga 10 minutes. If I'm not back, then Ragwa na jud nakaagwanta akong connection no so far. So this has been a problem ongoing dito sa bahay or kahit doon sa aming faculty room. So I'm also sure na napod na yung problems on your end. But again, thank you for joining with me this morning. So by the way, I have already started recording. So if you don't want na may ma-share na mga unwanted informations, no, kindly make sure that your microphones are turned off. And sometime later pa naman ako mag-ask na ma-open kayo ng cameras for our attendance. But then for now, you're free to do whatever you want so long as hopefully you still listen to the lecture. So as you've noticed, most of the activities in this course there will be a lot of essays. So you'll be expected to actually answer as many essays as most of the modules would like to have. Kasi majority dun din ng mga questions sa modules ay mga essay. So it's not your typical math subject where you are required to solve non-stop. Not really that. There will be instances na magsosolve tayo, but for now, let's have the more of the qualitative side of mathematics, meaning let's try and I'll try to define mathematics as much as I can. I have read some of the answers from your classmates earlier about what they think is mathematics. They define mathematics according to what they've seen so far. There were just many there were videos that were shared to you last time about the nature of mathematics, and I hope may idea na kayo no kung ano yung mga magiging topics that will be included here in the mathematics in the modern world. So if I ask you the world would be better without mathematics, would you agree or disagree?
I will agree, ma'am.
Napabay mo second emotion? Others, agree din ba?
Agree, ma'am.
Ah,
Silently agree, ma'am.
Oh, sige. Well, I will not take it against you, no, if you will agree that the world would be better without mathematics, because this is a question not intended to judge who you are, but yes, it's a matter of preference, of course. Some would agree, majority would agree, I suppose, and then some would be neutral, and then maybe a little bit of the curve will say yes, no, we don't agree, because if we actually think of how mathematics has been taught in the classrooms, how it's difficult to associate it to something useful, although we know it's useful, but we have not yet reached to a certain degree where we think na kanang ani siya ka-important na pag wala siya, you can actually die. Mga inana ba nga kanang kuan, inana na level. So I see some here in the comments saying they disagree. To some who agreed, it's all right. It's fine because if you did like mathematics, you would have not chosen your course as of now, no? Some would have opted to go for mga engineering courses or a bit related to mathematics, or if not, in general, even if you find mathematics difficult, kanang you still know, I mean, you still appreciate what is in that mathematics. But then to others, majority, I'm pretty sure isa sa mga hatest subject talaga is mathematics, no? Kasi nga it's a way kasi yung pagka-deliver siguro, or it's so technical, and sometimes, and not sometimes, most of the time we hate technical stuff. We would like to give it to the people who has who enjoys more of having the technical stuff. So it's understandable. But why do you think sometime hindi ko sasabihin na panalo yung agree, panalo yung disagree. Again, it's your personal opinion. It's something na kung wala naman yan, you will not be starving or you will not be dying. Yung mga ganun na bagay. So it's alright. Now, what you're seeing here is a picture of different things. No, marami pa talaga dito, no, mga nag-disagree kasi they perhaps may mga na-realize na mga nakikita na kanang math is everywhere. So let's see how math is everywhere, no? So suppose this thing, if you are to define this, how are you going to define this? Pictures. Mga adjectives. For sure, some of you will baka
Color.
'di ba? Dami-daming pwedeng i-describe, no? But how about if I ask you to describe it mathematically? Would it be possible to describe this mathematically?
Ano ma'am, na yung mga shape.
May mga
Yes,
shapes.
ma'am. Yes. Patterns din po.
May mga I see. So, yun, no? But then, okay, okay, sige. Maraming maraming mga observations yung nakikita ng karamihan. But then, we are hardwired in a way na if you are asked to actually define this, you wouldn't think of it immediately as something na pwede na may associate sa math. We are used to defining things using adjectives in the language adjectives, but not more often in a more katuloy mathematical aspect of it. To some, yes, but to the majority, it's easier to just describe it as beautiful, colorful, yung sabi nga kanina, mga ganun na bagay. It's easier to do that. But then, if we are to actually dig deeper to the details we are seeing here, that's when you can see shapes, you can see patterns, you can see a lot of things that could be associated to mathematics. Now, kailan mo nagsimula ito? Kasi sometimes yung tanong lang, no, sana wala ng mathematics. Yun lang naman talaga yung But how did we have mathematics? Bakit there was a need of mathematics? Because mathematics was not just something that was developed just because we would like to torture anybody who has no interest in this subject. Hindi ganun yan. So how is mathematics invented? How was mathematics invented or is still being invented? So let's look a little on the history of things, no? On the history side of mathematics. Ito sa taas is Shango bone, a prehistoric documentation of the first kanang mathematical use daw kumbaga. So it's not yet sure whether it's used for accounting ng mga prehistoric people. During the prehistoric era, yung number lang naman nila is one and many. But I think at some point, naging more advanced na sila that they started to tally things. So it's not sure what they're tallying in the bones. I'm not also sure kung makita ninyo kaayo ang mga kanang murag strip, mga little kanang dents sa bone. And we also have hieroglyphics here, the Rosetta Stone, and even the pyramid. So bakit ba may mathematics? Before it was even called mathematics, after the prehistoric period, yung civilizations natin were usually located on the river sides. The earliest known civilization, which is the Mesopotamian civilization, no, yung mga Assyrians, mga ano pa ba dyan, Hittites, and many others. Basically, Middle East regions, which is the oldest civilization, in China, in Egyptian civilization, all of these civilizations were located beside rivers. It's quite impossible to actually discover large civilizations that are located somewhere layo sa river. Because if the civilization is beside the river, they can have the water resources they need for farming or agriculture and kanang transportation. They can use that. Unfortunately, one of the downside of living, kasi yung Egyptian civilization, they were in the Nile River. Yung Chinese civilization kay nasa Yellow River. And then the Mesopotamian civilization kay katong nasa Tigris Euphrates na rivers. So what happened there? So these civilizations, although they're thriving, because they're living beside rivers, it so happened yung mga natural phenomena where magbagyo, maapaw ang sapa. Although it's good because once the river overflows, it brings fertile kanang nutrients for the soil. It's also a problem for the people living in that civilization. So what happened is that they used mathematics to address that problem. Ano-ano ba yun? Yung sabi ko kanina, irrigation problem, agriculture problem. So they used mathematics to actually address certain problems. It's not yet called mathematics, but that's how they solve it. They invented, for Egyptians, they had trigonometry as part of their culture, no? In inventing the pyramid, they actually employed trigonometry there to make it as closer to perfect as what they have in wanted for sa pyramid, and to other civilizations as well. Again, to address certain problems. They used accounting para ma-monitor nila yung kanilang ins and out ng mga income sa kanilang lugar. Statistics to monitor the people in their area, and many others. In fact, one of the greatest example of massive statistical use was when kanang sa Bible, God, katong time nagpa-register ay niadto si Mary ug si Joseph sa Jerusalem. The purpose of that was not for Jesus to be born in the kanang manger, was actually to register him upon birth. So magpa-register sila. Basically, murag sa to ba PSA din ay parehistro ang mga tao. That's one of the example of statistics. Again, they're using mathematics during that time in a more practical way. But it doesn't mean that this is something that is available for everybody. Kasi only few people, kaya nga may mga experts nung time na yun. There were just people who will be allowed to do the accounting. There were only people who were allowed to create, to become architects, engineers during their time, and the rest would be workers. But how are they going to be paid? Yung mga ganun na bagay. And that's when they actually employed mathematics. So kailan ba siya tinawag na mathematics? So it was actually during the Greek time where they actually termed mathematics. It was actually mathema. So yung alam niyo mga tao nung way back ancient times, masyado yun silang literal. So ang mathematics is just as literal as it meant. Not really numbers, not really equations, but it's actually more of what to use it for. It's to learn. It's a science. It's a study. Again, learning process. Technically, mathematics is this. Ngayon, sa ngayon na definition niya, it's a science of numbers, operations, many other processes, which means mathematics is not a subject. It's actually a discipline. If science is the process, kasi science is actually what the process is, mathematics is actually the language of sciences. So, dito, if you are the language, you're actually the one explaining the phenomena. That's the reason why majority ng mga laws ng sciences is in equation. Kasi that's how they are trying to encapsulate kanang mapa-shorten gud nila ang isa ka theory, isa ka phenomena in by just using symbols. And part of mathematics is not just merely solving. That's just actually a component. Majority of the things you do there is you interrelate. May mga generalizations kang gagawin, abstractions, and many other things na a latter part kay kanang ang mga generalization pwedeng gamitin ng mga tao. So that's actually the purpose. It's not something na, kunwari, if you hate a certain aspect of math, like you don't like X, Y, yun na, formulas, maybe it's not actually mathematics that you don't like. Perhaps it was actually the experience, the teacher, for example, or just the subject itself. Not the entirety of mathematics. Kasi kung ang hate mo lang naman is X and Y, baka yung algebra lang naman pala yung hindi mo gusto. Or the geometry side of things, yung mga shapes and the likes. The combination of algebra and geometry, which is trigonometry. Or kanang the higher forms of algebra, geometry, and trigonometry, yung nila, calculus. Or bet mo naman yung arithmetic or plus, minus, divide, og times, it's all right. Because again, not everyone is inclined to mathematics. There are people who are more inclined to different things. Kaya nga tayo may mga individual differences. So, hindi lahat kailangan i-insist. And that's also the same reason why we have different kanang courses, why we have different jobs. because there are people who are intended to use this, and there are also people who are intended to practice this. So in our case, since I'm a math teacher, I'm more intended to use the mathematics in a more kanang medyo abstract manner, X and Y and so on. There were also the ones like engineers and other people who has mathematics as one of their major components in their job. But there were also jobs na hindi yun kailangan. But at least a part of mathematics. Ano ba yung mga parts na yun? So, yung parts na yun na aking sasabihin is according to Arthur Benjamin are the reasons why even if we have different kind of inclinations in math, some could be learning faster in mathematics, some could be learning a bit slower in mathematics, we are still required to learn math. Because partly kay part siya sa atong curriculum, no? Yun tayo choice, but because at some point you will be asked to calculate, regardless of how complicated or simple the calculation is, it's still calculation. And when you calculate, you are not just calculating, you are observing things, you are analyzing things. Why is this the calculation? Why did it reach in this manner? Minsan pag nag-budget lang ka dira, you will still be employing a lot of faculties in your brain. You could be checking what's happening in the calculation. If nagkamali ka sa calculation, you would be checking where the wrong thing is. So it doesn't really mean na katulang itong mga formula na gina-introduce sa classroom. As simple as, kunwari, may pera ka dyan, binabudget mo yun na ganyan, that's already a calculation on its own. And that's one thing already why you should know your mathematics para di po ka mailad. And the other reason is application. So you apply those things. Kunwari, you will be learning in math, one of the things you will be taught is to identify patterns. And you would see how very important learning to seek pattern is. Kanang ma-identify gud nimo ang situation and you can actually conclude what to do next, what to avoid in the next time you encounter the same things, because our brain is more susceptible to learning in pattern. So math as an application does not just really have to be katong lang lagi mga formulas and the likes. There could be professions who require those. As I've mentioned, may mga chemists tayo, scientists, mathematicians, engineers, and the likes who would be more of the katong technical stuff of math, kanang stuff ng math. But then, kanang mga ordinary people could still enjoy the application on math on their own way. Ikaw, kung if you are tending on your own needs, kahit yung nagluluto ka, you will be, estimating a lot of things. That's already a mathematics in a way. Or you could be learning how to become more logical, how to become more analytical. At some point, it's not just merely solving in a way. You are being taught as well different attitudes. You could be taught perseverance, you could be taught patience, and many other aspects. That's why one of the reasons you have to learn math is also in a way inspiration. So sa akin nga I see this as an attitude building, a character building discipline, aside from it being very technical. Kasi in some instances, kunwari ako pag nagsosolve ako, lalo na pag masyadong mataas yung sinusolve ko, it took me a lot of time, and it was not just one time, it took me several times to actually achieve the correct answer, and yung satisfying feeling of seeing the correct answer and not actually stopping despite of the difficulty, it's already a journey on its own. And so, at some point along the way, while learning that process, you also learn a lot of things aside from the solving process. So in a way, I am a bit inspired. And the beauty here is, pag nag-solve kag math, bisan pag lisod kaayo siya, we only have one universal answer. Despite of the processes you're using, we are all expected to have the same answer. So if you are to complain of the answer, you should be able to prove it. Ana lang man ang murag logic sa math. So it's still with numbers, by numbers. Mga anak gihapon ihang kanang reasons. And for other anong kwan sa inspiration, no, some mathematicians have developed mathematical state as mathematical equations and many other things due to inspiration. Example dito is Galileo Galilei, his invention of telescope. Leonardo da Vinci, who was famous for many other things. Actually, he was the first one to to design planes, mga sasakyan na lilipad balang araw. And he was around 15th, 16th century. So he was way ahead of his time. It was not materialized not until late 19th centuries. So that is just an inspiration, mga futuristic thinking. René Descartes, he invented the Cartesian plane or yung XY plane, which is the basis of the grid and the basis of the GPS system, yung GPS na program. And ang reason lang yun pag-invent ni René Descartes anang Cartesian plane kay langaw. Sa kaboard niya nagtutok siya sa langaw. Iya din githink asa man ang langaw ganina. Asa na pud na siya motugpa sunod. So for that, he devised the XY plane or the Cartesian plane. As simple as those could become big in the future. We just need people to do some innovation on an existing thing kasi ganun yung nangyayari. But then again, we are not expecting that everybody knows that. Some might know those things, but others will not know about it. But it exists. May mga ganung bagay na nangyayari, and yun yung mga na-overlook at some point when we talk about mathematics. Now, isa din sa pinaka-important aspect why we cannot actually escape mathematics is that the world is governed by numbers. Kahit saan ka lumingon, majority wins. We elect our officials because we chose them according to the majority. You can be powerful if your bank account has a lot of numbers in there. Or even in nature, even in the natural side of things, in the animal world, they can go against predators if they will exist in numbers. They are safer in numbers. Kahit tayo nga, we as a society are always inclined to be with other people because we feel stronger in numbers. Remember, katong napay mga face-to-face, pag ipatawag gani ka sa office, mambiraj kag kauban or whoever is calling your attention because you feel safer kay naa kay mga kauban. Again, that's innate in our kanang system. It's innate in us that we feel safer, we feel more belong if we have the numbers with us. So, ito mga random lang naman ito na representations, no? So, these are random representations of numbers. It will not mean anything because, again, these are just abstract numbers. But then, it will start to have meaning if these numbers are connected to a certain aspect, a certain, kunwari, i-connect siya sa mga presyo, the number becomes meaningful. There's also, kung i-connect natin yung number na yan sa mga bagay-bagay na yung nakikita sa screen, the number becomes meaningful. Kasi if it's just a number alone, it doesn't mean anything and it doesn't make any difference. Kunwari, sasabihin ko sa inyo, each one of you will receive 1 million from me. You cannot be happy by just being told, you will be given 1 million. Because what's that 1 million? It doesn't mean anything unless I put a quantity to it. I put a definition to it, a description to that number. So if I did say 1 million pesos, it could be something that you can be happy. But just 1 million alone will not mean anything. Kasi nga, number is abstract on its own. But if it's related to something a bit kanang concrete or really concrete, example kanidere, it gains another meaning. The same reason, nakatong bata pa ka, pag tudluan gani kag counting, ipaanana yun imong kamot, 1, 2, 3, isa-isa dyan imong kamot dire. Kasi naa-associate ng brain mo na pag 1 na siya, isa lang na siya ka-concrete thing. Or tong kindergarten or elementary, pag nagpa-add ka dira or subtract, you will have to, magpa-count kag numbers. Yung 1, itapad yun na niya og kanang agoy, let's just say 1 apple, 2 oranges. Kasi our brain understood better if an abstract thing is connected to a more concrete thing. So the same with numbers. So what do we mean by number really? So a number is just a value, not unless, or a figure on its own, unless we try to connect it to quantity. And at some point, the number makes mathematics a non-discriminating nature kasi in math, kahit paanong pag-usapan natin, once it becomes a number on its own, wala naman na siya. Kanang number na lang gid na siya ba, kumbaga, wala na siya ilaing kanang qualities. And also, the number, since it's a representation of the concrete world, it's easier to manipulate. It's easier to calculate. Halimbawa, you have 1,000,000 mangga there, kanang nang harvest mo mangga, and each carton ng mangga dira mag-contain siya 100 ka buok, and you're supposed to count everything. Do you have to count everything one by one? It would be easier to just calculate it using certain formulas perhaps. That's how logistic works. Kanang companies like nag-automate mga factories, do they have to count it on their own? They can be using calculations, automatic calculations for that, and it makes easier. So that's how numbers aid the calculation process. You don't have to really hold the concrete object one by one and do the counting. It would take years. It would take ages for you to complete the task that would have been completed if you can just, represent it in numbers and then compute it. Halimbawa, sa bank, do we have do the banks do people who works in who work in investment have to consider count pa talaga, isa-isahin pa talaga yung pera and all, if they can just do the calculations and other stuffs through mga automatic processes. Kasi that's what the numbers are for, to represent a certain concrete, whatever that those concrete things. Then we have types of numbers. So just para a reminder to everybody, no, I'm pretty sure these numbers are introduced to you in your junior high school, perhaps somewhere along the senior high, if I'm not mistaken. But if it's not introduced to you in senior high, along your junior high, these numbers were already introduced. And I will not expound on this further, just to to remind everybody, no, na we have different numbers and they have different functions. So what we often use in the real world are just the counting numbers. And at some point, a little bit of fraction, but not so much on this. But these numbers are still important, especially sa mga formula. We might not be able to appreciate those things anymore, no? Kasi nga naka-automate na tayo lahat. We have devices we can use to actually perform tasks that we used to be manually done before. But then let's remember that the cell phones you're using, the computers you're using as well, and whatever runs in technology, there will always be mathematics behind it. So without those things, it would be very difficult to actually experience the convenience we have now. So it's a collaborative effort between many minds, among many minds, to actually come up with something as handy as a cell phone, a little computer as it is, that we don't have to encode, do this and that. So, isa to siya sa mga kuan good beauty. So, speaking of numbers and how it has changed, how dealing with numbers have changed all over time, no? There is a specific number, we call it the golden ratio, that has become a craze among many mathematicians during the Renaissance period, if I'm not mistaken, or early medieval period, 15th, 16th to 18th century. Kasi majority ng mga famous people during that time were actually obsessed with the golden ratio. So what do we mean by this number? So this is a special number. At some point, we call it the God's number, the divine number. There are many names on this, but it's more famous with the term the golden ratio. This number, I first heard about this when I knew about this actually was when I read the Dan Brown's Da Vinci's Code. That's when I read the Golden Ratio, and it has interested me for a longer time. So when I taught MNW and found out that it will be taught in the class, I had to read more about it, and it was something of mystifying and amazing journey because what this number represents, it basta ano siya, it's actually what defines the universe. Or if we are to define how things are done naturally, you would often find a golden ratio as one of the definitions. So in values, although it's an irrational number, when we say irrational number, when we convert a fraction into decimal, iyang decimal value kay mag-extend indefinitely. So that's what we call irrational number. Mas famous siya sa 1.618 na value. Pero that's just an approximate value. Kasi the more that we extend it, the more that it becomes 1.618. So the goal really there is to actually reach the point na 1.618. But I'm redirecting things. So going back, ito yung value ng golden ratio. We have 1 plus square root of 5 all over 2. So, ano bang meaning nito? If you watch the videos linked to you some other time and I ask you how to define mathematics, part of the video there, lalo-lalo na yung may kay Jose Villa, yung may pattern that started actually from a shell, a Nautilus shell, and then extends until sa, I think, Alindanaw, man siguro to, no? If I'm not mistaken, Alindanaw, pag ba na sa inyo nga term? Dragonfly, ba? Basta, nag-extend hanggang doon, yung pattern, kumbaga, ng golden ratio. So, from a Nautilus shell, accordingly kasi, yung shell ng Nautilus, nagadagdag na siya, yung curve, nagadagdag siya as time goes by. So, yung pattern na nakadagdag ato sa iyaha, if we are to measure it, ang ratio niya is following the 1.618. So, in math, yung technical side of things, we have the golden triangle and the golden rectangle. So if we are to extend these rectangles endlessly, they will still be extending with the kanang dimensions na kunwari sa triangle, we have 1 as our base and always kanida rin na side will be 1.618. Not technically na 1.618 ang value, but ang ratio nilang duha kay 1.618. Ratio is kanang yung kag 1 is to 2, 1 is to 3 na for every one measurement diri sa iyahang base, ang measurement diri kay 1.618. And that would also be true to the rectangle. So we can extend this endlessly and we will still be getting the same ratio, which is 1.618. Now notice, I'm not sure if you have heard of Fibonacci numbers before, but these numbers are actually, if you compute the Fibonacci numbers and get their kanang ratio, which will be discussed in the next kanang discussion, no, in the form of video, kay kaya siya 1 divided by 1, 2 divided by 1, 3 divided by 2, and so on. The higher the number of the Fibonacci is, or the Fibonacci sequence, the closer we get to the golden ratio. So, just like the sunflower and the Nautilus shell, kato sila, pag i-pattern to sila later, the more that it increases its number, the more that it becomes closer to the golden ratio. Kasi daw, the world exists if we are to check the majority of the patterns and the ratio of all the things existing naturally, we are to expect the golden ratio in those things. In fact, these are just some, according to scientists and mathematicians, the galaxy, yung mga curve ng things, painting, art, architecture, engineering. Golden ratio has been used in many other kanang disciplines, kumbaga. In fact, although they say that defining beauty is difficult because beauty is subjective and beauty is in the eye of the beholder, we can actually objectively define beauty. It's also the reason why our brain can appreciate kanang bang kaya na to maingon nga, "Oh, gwapa siya," without kanang kanang napakay ka ng mga tawag ani, hmm, reservations kumbaga ba. Gwapa ka kanang maingon jud kag gwapa not because napugos ka or kanang maulaw ka nga ma-hurt ang feeling or gwapo ana good. You don't say that, but you actually appreciate that it's nice because our brain can read the nice can read it as it is. Can ma-define maano niya, ma-determine niya ang pattern and ma-recognize siya sa atong brain. That's why we can actually call something ugly because our brain cannot actually understand how it's being presented to us. So kana na kay mga kaya sasabihin din nila naka-preference din siya. But technically, majority of the faces where the golden ratio exists, well, actually kanang kaya siya dawaton sa imong brain ba, kaya nimo siya kanang tutukan, kaya nimo siya tan-awon and ma-appreciate nimo iyang beauty because masabtan siya sa imong brain. The brain can read the said pattern. So in the face, kung baga kay kag now and then you will be if you are to claim that you are really beautiful, of course there's a way to prove that. Again, you will just undergo to kanang i-check lang nimo ang ratio sa imong kuan nga dapat ang kataas sa imong ilong with respect to the length here and katong kabukad ana niya dapat naka close to 1.618, not exactly 1.618. Yung distances na iyong eyebrow pati yung arc na iyong eyebrow ang kilay is life, you can actually use the 1.618 there and it will still be seen as something kanang recognizable by your brain. So kaya nga pag may mga weird stuff medyo lahi imong kanang kuan ana sa iya ha, lahi imong basa ana sa iya and you will have a different reaction because your brain is trying to decipher the fun. Kaya diyan din papasok yung dapat kanang symmetric, yung mga ganun because again, your brain wants things being observed in pattern kay mas ma-recognize na niya. Now, in the body, interestingly, and I did read this one before during the in the Da Vinci's Code when Professor Langdon was actually having his lecture about the golden ratio. Katong imong palm, pag i-measure nimo na siya, and from the base of your palm towards your elbow, it should be close to 1.618. Your head to your navel, gikan sa mong pusod pababa, the ratio should be close to 1.618. The length of your arm with respect to your arm itself would actually have to follow a close to 1.618 kasi yun nga accordingly we are designed in a manner where we stick to a certain number parang siya ato ang reference ba so if you do believe in a divine omnipotent power so we could have been really designed to something natay gina-embody na something and that something was actually embodying the 1.618 hence yung creation sa atin is closer to that the replication of us is close to that number accordingly now this one is the Vitruvian Man as created by Leonardo da Vinci himself so this is according to him if the man possesses all the golden ratio kasi majority ng mga works ni Leonardo da Vinci was actually related to the golden ratio. Isa na siya sa katong medyo na-fascinate sa idea of a golden ratio. So pag i-extend daw nimo imong body, you can create a perfect square with your arm and the length of your head to toe or toe ba yun siya? Basta, ano siya? Or if you are to extend some parts again of your body, extend po nimo imong arm, extend nimo imong legs and the likes, it's possible to create a pentagon in there and circle sa imong body. So that's when you have all the measurement of the golden ratio. But for sure, not everybody of us will have that kanang perfect kanang composition. That means we have individual differences. So it's all right. Pero yung yun lang nga, yung brain natin would appreciate it more if it's closer to the 1.618. Now, in art, there's also a craze of the Fibonacci, I mean the golden ratio during that time. As I've mentioned, Leonardo da Vinci was so obsessed with golden ratio. He painted Mona Lisa with that in mind. There was also The Last Supper, another work of his, which was also based on the golden ratio. We have the Sistine Chapel, itong medyo malaki-laki dito na painting sa ceiling ng Sistine Chapel. And then we have the girl with the pearl earring here, which is a controversial painting. If you have seen this painting, seen a reaction video, something of this painting. And the golden ratio at some point was also responsible. Kakita mo ng mga portrait na bisag asa ka dapit maglingkod, magtindog, whatever position you are from the painting, it seemed like the eyes of the picture in the painting is looking at you. Kana siya na phenomena. Although there's a technique on that in painting, at some point, most of the painting who has the 1.618 ratio on them were actually, lalo na pag na mata ang drawing, it seemed like the eye of the one painted was staring at you in all directions. It's inescapable. I don't know why those things exist, but it does exist. So siguro part of the beauty of the number itself, maybe. Then we also have golden ratio in architecture. The lower part is the Parthenon, yung temple ni Athena, the goddess of wisdom sa Greek mythology. And then if you are a fan, I am a fan of Greek mythology, so it's also very interesting. We have another one, which is the Taj Mahal, a temple made because of extreme love for his wife. No? So these buildings, they were actually found out to be displaying the golden ratio. And surprisingly, according to my research, by the way, most of the buildings, although the Parthenon was actually not in the very good state right now, but given that it's been 2,000 years since its building, it's understandable. It's even surprising that it has come to this point na makitaan pa ni mga remnants sa Parthenon. But then, it's because of the way it's built, perhaps because part of the foundation was it has to resemble the 1.618 ratio. Maybe it's also the reason why it stood the test of time. Even the pyramid and some other ancient structures, they were found out to have 1.618 at some point in the construction. And it could have been one of the factors why they were able to stood the test of time, who knows? But they are just amazing kanang structures na satisfying siya sa tan-awon, or am I just the only one satisfied? But it has a certain appeal. Kaya nga siguro yung golden ratio tinatawag talaga na God's number, because you are drawn, your brain will always be drawn to those things that are made in accordance to the golden ratio. So, in all these things, of course, may mga definition ako na present about mathematics and how it's being defined technically, how it's used in history. Now, let's see how some of the mathematicians define mathematics on their own. So, according to Henry Poincaré, he's a modern mathematician na ni siya, mga early 20th century, no, late 20th century. So, mathematics is the art of giving the same name to different things. Earlier, I said that in mathematics, this is one of the subjects that avoids discrimination because it just name all things in the same manner. Example, the doors, rectangular doors, rectangular windows, we have rectangular tables. All things rectangle will just be labeled rectangle in mathematics. Or we could have ball, we could have a wheel, we could have hula hoop, we can have a coin, whatever. But still, in math, they could just be labeled as round objects, or circles, or spheres. In other words, in mathematics, if they resemble the same thing, they can be grouped in the same thing. But in actuality, they are different things. So that's one. According to Rene Descartes, no, um, he believes that all things occur mathematically. We will have topic on that, patterns in nature, but yes, we do exist. Our life cycle is in pattern. The world, if we follow how the world is built, it actually followed a certain process, and still the process is in a pattern. We learn best if it's in a pattern. We do things in a pattern. So perhaps we actually occur mathematically because mathematics is basically pattern. And according to Hardy, um, there's no ugly mathematics. Everything is permanent. Kasi if at some point kasi kahit sa ating body, we do have the golden ratio. And if we define beauty using the golden ratio, then since we have the golden ratio, it's also kanang murag part of the generalization that there's no ugly thing there. Kasi if we follow a certain pattern, naman na dayon ng itong mga ratio dara. So, there might not be any ugly mathematics at all. According to Albert Einstein, as far as laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality. So, ito yung sinasabi ko, law. Although it's a law, like law of gravitational pull, law of energy, yung mga law na yan, kahit nga si Einstein, he created his formula E equals mc squared, which is the formula of the universe. It's not actually just that. Yes, there is a formula, but it's not certain. Everything is uncertain. So if we are to say na mauna jud ni siya ang final, no. Because at some point in the future, it could be kanang proven otherwise. So there's no certainty in here unless it's certain. And what are the only things certain in the world? Death and change. And even those kahit pa certain na mangyayari ang death and change, we're still not certain when those things will happen. So in yes, we have mathematics, we can present them in equations and the likes, but it's not what the reality is as it is. Kaya nga may differences tayo between practice and theory kasi they could be quantified into one single equation, but then may mga instances na pwedeng mag-change na siya kasi may mga factors that could affect and may cause changes. And many other mathematicians here who are going to define, and many more, George Polya, Temple Bell, and many other. But one of the things that I like to conclude person's definition of mathematics that I'd like to use as a conclusion is kay Galileo Galilei, the inventor of the telescope, and was one of the person who have introduced us to another part of outside the world, the universe, kumbaga. Because by using his telescope, we were able to see what is outside Earth, and that was Jupiter, yung isa sa pinakaunang nakita niya, no? Aside from Venus, which is the morning star. But then, mathematics is the language in which God has written the universe. So since if we are to believe, no, na we are made according to a replica, we have a certain then kanang natay murag gina-embody ba dapat mas close ta ato sa iyahan na image, and the number that is close to that is also found in other creations, and those creations exist in a manner where they occur naturally in a pattern. So if things will have to occur in a pattern, and not just within Earth, it has to occur in the entire universe, then since there's a pattern there, we can actually see mathematics there. And with that, we can say that mathematics is the language. Earlier, no, science is ang language ng science is mathematics. But science could also be seen everywhere because it's a process, and we are seeing many processes every day. So, ang one way to actually interpret that and become a bit more understandable to some, not to the majority. Kasi kunwari, the universe can be encapsulated into E equals mc squared. And who would have known na pwede daw siya i-represent as equal as E equals MC squared. So that's just one way of parang defining ba that yes, maybe at some point we are really designed by an omnipotent power, whatever you call that omnipotent power. It could be God or it could be something else that you call that. But there could be that. Dili kay siya scientific, more on theory based. So we end the discussion there. Thank you for your participation this morning. No, so pahabol ni Einstein. So do not worry about your difficulties in mathematics. I can assure you, mine are still um, greater. So, as much as I'd like to listen to many of your realizations, and I don't know, we have very limited time, but I hope you did learn something about, you know, what mathematics is more than what we are confined to believe as a society, because it's not often where we are given the privilege to actually learn. There's just more than what we actually see, that it's not just merely this and that. At some point, some needs it better than us because, again, we are just normal individuals. But then the result of the endeavors of those people who have engaged their lives, spending more of their time looking into what mathematics can do for the society, we were actually the ones who experienced the convenience of it. As I've said, nakikita naman natin yung result as how mathematics are employed. Hindi natin kailangan na talaga mag-solve and the likes. Even the calculators we are using, which kahit pa, ironic masyado na kanang pag nana kay calculator, even 1 plus 1, ipindot na nimo sa calculator pag nag-solve na ka. That's so ironic. But we have become very dependent to that extent. Nga product din naman yun siya ng mathematics. Tapos ang imong gina-answeran kay mathematics gyapon. But nevertheless, yun yung ating topic, no? So there could be, nawala ko. Okay, bigla akong nawala. I think I'm not sure if I'm already back. But yun na. So expect na may marami pang essay, no? So I'd like to listen to more of, read more of your generalizations as we go further. So by next week, a little bit announcement, no? Nawala na jud ko. Like totally wala. Gipahuman lang gid akong klase. Internet. Are you okay? The downside of technology. All right. So hopefully you can still hear me. Thank you. Sige, so by next week, no, the next lectures will be recorded. So you can just kanang